All right, so here we're going to try and answer the essential question: how can you determine how many solutions a polynomial equation will have and whether a polynomial equation has imaginary solutions? Great question. So let's get into it in 1 second. First, I want you to recall degree of a polynomial. So these are polynomial expressions. Take a minute, identify the degree of each, pause the video, do that, unpause when you're ready to discuss. All right, so hopefully you came up with it for number 1, it's 4, and we're getting that because it's the largest exponent. For number 2, it's 3, that's our largest exponent. For number 3, also 3, our largest exponent. Notice here, just side note, we could have combined these, but it doesn't change the degree. And number 4 is 6, because that is our largest exponent. Okay, so you may be asking yourself, well, why did I need to do that? Well, it's because degree is a really important part of polynomials for many reasons. We have seen some already, such as end behavior, but they lead us to understanding the fundamental theorem of algebra. Or they are an important part of the fundamental theorem of algebra. I guess they don't necessarily help with the understanding of it. So, what is the fundamental theorem of algebra? Great question. Glad you asked. That's why I have it up here. So the theorem says, if f of x is a polynomial of degree n where n is greater than 0, then the equation, f of x equals 0, has at least one solution in the set of complex numbers. Okay, well, that's interesting. What exactly does that mean? Well, here's a corollary. If f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, each solution repeated 3 times is counted as 3 solutions, and so on. Okay, maybe you understand a little bit more, or maybe you're more confused. So let me break it down for you. What is this telling us? This is telling us that the degree of a polynomial is the number of solutions or zeros that polynomial will have. That's what the fundamental theorem of algebra is really telling us. Now, it sounds more complicated than that. Really all this is saying up here is, well, those solutions don't have to be real numbers. They can be complex numbers, and also understanding that all real numbers are complex numbers. What this is saying down here is when we have multiplicity, which we've talked about already, we need to count those as independent zeros, right? So if I have a 0 with a multiplicity of 2, I'm counting that as 2 zeros, even though it's the same value. So again, the key part is the degree of the polynomial is the number of solutions or zeros of that polynomial. The reason why that's really important is it helps us understand when we are solving a polynomial, how many answers are we looking for? Okay, so let's look at an example, or 2 examples, visually. So here I have the function x to the 4th minus 2x to the 3rd minus x squared plus 2x equals 0. And then I've also graphed this polynomial for us. So the first thing we want to know or note is the degree, right? And this polynomial has a degree of 4. So what that tells me is if I was to solve this equation, I should have 4 solutions. Now, remember graphically, solutions are x-intercepts. So I can see I have 4 x-intercepts. And if I have x-intercepts, then those are real solutions. So I have 4 real solutions, which means since I need to have 4 total solutions, all of them are real, I have 0 imaginary solutions. Okay, well, let's look at the next one, and if you're a little confused, hopefully this will make a little more sense. So here, again, I've got degree 4. So I know that I need to have 4 total solutions. If you could see me right now, you would see that I'm holding up 4 fingers. You can't see me though. So are those real or imaginary or both? What are they? Well, remember real solutions are x-intercepts. I can see that I have 2 x-intercepts. So that means I have 2 real solutions. Well, if I know that I have to have 4 total solutions, by default then, I know the other 2 solutions, have to be imaginary. Can't write. There we go. 2. So 2 plus 2 is 4. Now, we could say, well, what if each of the real solutions had a multiplicity of 2? Because we've talked about that, right? But we know that if it has an even multiplicity, then there should have been a bounce at the x-axis there as opposed to passing through. Okay, so for these 4 examples, I want you to just identify how many solutions or zeros each equation should have. And all I'm asking for is total number, not the difference between real and imaginary. Pause the video, do that, unpause when you're ready to discuss. Okay, so hopefully this was pretty straightforward, that we're just identifying the degree of each of these, and the degree is what tells us how many solutions or zeros. Now, also part of these problems is recognizing when we say solutions and when we say zeros, we're really saying the same thing. Solutions is because the equation is already set to 0. Zeros tell us that our very first step would be set the equation equal to 0 and then solve, which would be finding the solutions. So when we're trying to find solutions or zeros, we're really finding the same thing. Any questions? Okay, and we're not actually solving them here. We're going to get to that in a little bit, but we want to recognize how many solutions should we get. All right, so again, the big thing is understanding the fundamental theorem of algebra. Sounds very important. It is. It's kind of a big deal. But it's really just telling us something very simple, and that is how many solutions or zeros a polynomial is going to have. And it's just based on the degree. So this is another reason why it's important for us to be able to identify the degree.